recording now. If you have any questions, best is if you speak up. I don't always look on the chat, but you can also write them in the chat and hope for them to be noticed in time. In the part 2 of our lecture, we will be focusing on more UI-oriented work. We will, since in the first part we only looked on the very core mechanisms. Here, the goal is to get the right skills so that you will be able to create a graphical application for whatever purpose you might have in your lab. And we will be using the Qt framework for this. So let's quickly switch to the other virtual machine where everything is still not set up, and I can show you how to obtain it. You should have Visual Studio already installed, either from the lecture last year or from watch the exercises that had place today morning. I showed quickly how to install it. If you haven't participated in either, you can just review them. They are posted online. So after Visual Studio has been installed, there was one more setup step that I have not shown in the morning. It will just ask you which UI or configuration you prefer. Once it starts up, that is, of course. And here it's also asking for login, but this can be skipped. And I prefer the general and light theme, but of course, whichever theme you prefer, it is up to you. The dark theme seems to be very popular nowadays. And then it basically will start to the screen that we have already seen in the morning. Just that since it's a new installation, it does not contain anything that would have been made with it in the past. To get Qt, we want to download it. It is a framework. A lot of Linux UIs is created using that framework. It allows you to create platform-independent applications in the sense that you can compile the same code for Linux, Mac, and Windows, as long as, of course, you are not using any platform-specific API calls. But as long as you stick to just the API calls that Qt offers you, then this should not be a problem. Offline installers, that sounds good, but that will be, yeah. These are old things. That's also not. Finding the proper Qt download is a bit annoying because they want to sell you a business license, which you absolutely not need for pretty much anything. Qt is licensed under the LGPL license, which means that you can create a closed source application, link it with the Qt libraries, and just the only thing that needs to remain open source are the libraries themselves. And if you don't modify them, you just use the standard libraries, then you have zero work with that. If you would want to modify the libraries, you would need to publish your modifications. And if you would want to link the libraries statically so that they become a part of your binary instead of being separate dynamically loaded binaries, then you would need a license from them. But since they obviously finance themselves through licenses, they try to push you into buying one, which is not a good idea because it's quite restrictive. And usually Google gives you better search results than Bing. Here we have found it quite quickly. We take the Windows Online installer. There is one caveat. They will ask you for registering an account with them. So you can you have to register one online in order to be able to use the installer, but it's free, so you just need some disposable email address. We don't want to send any data. Our data are precious. Here you select that you are a single person and that you have read their license terms, which, as said, are mostly and this error comes unfortunately quite often recently with their code. Some of their mirrors are not working properly, at least for Europe. But usually if you just try it a few times it works, and if you would be stuck in an unresolvable issue, then the solution would be to manually specify a command line argument for the installer which mirror to use, and then it will also work. But as we see here, at the second attempt it worked fine. So we select desktop development with Qt 6.2, 6.9. 6.9 is a bit too new. User-defined installation, and then we can select which version we want. So I would recommend the 6.8.3 because it's a bit more mature than the 6.9. Of course, in principle, this is compatible source-wise anyway, so it doesn't really matter which version you select. I just selected this one since in the other virtual machine I have this exact version already installed. We don't need WebAssembly. We don't need LLVM. So assuming you are using a Visual Studio, then we don't need ARM. We just need this one. We also don't need this one. We don't need Android. The sources to have is quite good. Now, if you want to not use Visual Studio but some other development environment, Qt comes with an own development environment called Qt Creator, and it's functional. So it's by no means comparable with the full version of Visual Studio, but it's good enough, and for Linux and macOS it's the only thing you get easily anyways that would work out of the box. For Visual Studio there is a special plugin that makes a perfectly nice integration. I'm not aware if there is such a thing for Xcode, for example. So we take either this version or this version. This version is if you don't have Visual Studio. This one is if you have Visual Studio. And here there are some additional components. Some of these components are in fact only GPL, not LGPL licensed, meaning that if you want to use them in a closed source project, you cannot. You have to buy then the commercial license of Qt, or you have to make your project open source. Both solutions are fine. And since our primary goal is using a lab, so you would either make the application open source anyways, or if it's just a few people using it, it pretty much doesn't matter, since the sources are available inside your research group anyways. It only matters if you publish the things online, and most of the things that are only GPL or proprietary are easily replaceable with third-party, more liberal libraries. Unfortunately, the list here does not show which are licensed how. Even if you click on them, they don't tell you. So WebView is LGPL, from what I know. Keyboard is, I think, just GPL. Speech, I don't know, but it's one of the new ones, so it's probably GPL only. Serial Bus or Serial Port. One of them is definitely LGPL. The other one might not be. So Serial Port is definitely LGPL. Serial Bus might be a newer version which can support other protocols which might not be. Sensors isn't properly either, but generally this doesn't really matter, since, as said, for your application you can just go with the open source GPL version and just make your app open source within your group or publicly. And second, if you really need something, then it's easy to get a replacement. An example, for example, would be here this Qt Charts that's used to make nice plots for nice visualization, and this is unfortunately, at least the last time I checked, only on the available on the commercial or GPL license. But there is a replacement library called QWT, which is LGPL, and that library is it existed since over a decade, so it's very mature and has a lot of features. And in my own opinion, it is for scientific use more suitable than the Qt Charts. The style of this Qt Charts is more modern, which might look nice, but it offers you less information. While the older QWT library, which by the way is not made by the same people as Qt, is just a third-party library that is made for that framework by someone else, is really optimized for scientific applications. It shows you a lot of data. You can make nice legends for your graphs, zoom in the graphs, have scales on each side, etc. Everything you might ever want. While with this thing it might be a bit more laborious to get a view that would be suitable for a scientific application. So this, as said here, we can just keep everything, although which one takes... There is a component somewhere which takes quite a long time to install. Yeah, that's the web view. because it installs basically a full own fork of the Chromium browser, so that you can embed websites inside of your project, which usually is not really useful. There are of course edge cases where you might need such a thing, but yeah, just so you know that if, for example, you know that you don't need anything of this, you could just select serial port, and that's probably it anyways from the useful things. The HTTP server might be useful if you want to host some own website, for example, that you can control a device in your lab from your cell phone. Of course, how you connect those two with each other might be a different story. Our university has a quite strict firewall policy, so you would need to find some workaround for this, but there are reasonable solutions. For example, you could have a local Wi-Fi that does not connect to anything except your phone and the lab computer. That is a perfectly safe option, assuming the password is good enough. But for example, this is also just GPL or proprietary. Although writing an own HTTP server is surprisingly easy. I did that few times, in fact. Okay, but as said, you could unselect most of it, since you probably won't know, except for the serial port that is really useful in lab scenarios. The rest is not, and if you want the install to be quick, or you are on a measured internet plan or something, then of course you want to save the amount of data that is transferred. Now here the other group has build tools, and if you would want the non-Visual Studio option, this min-gv option, then it's a 17.06, then you need to install the corresponding toolchain, this one, for it to work. And then of course the last thing, Qt Creator, which you can install or not. We will install it here. And this thing is made such that it can operate with Visual Studio as a compiler toolchain, or with this Ming GW toolchain as well. So it's quite flexible, and yeah, and as said, it's functional. If you are on Mac or Linux, just use this. And last thing to say, there was somewhere a checkbox for debug informations. This takes a lot of space, and obviously therefore download time. These are debug files that allow you to debug the Qt installation that you have obtained. So if you get a crash somewhere inside some Qt library, and you would like to investigate why this happened, to be able to know which code line corresponds with the address in the DLL that triggered the exception, you will need this debug informations. Depending on how you intend to use Qt, it might be useful for you or not. I always tend to install it, since I find it, at least in edge cases, nice to be able to look inside the Qt DLL what exactly crashed and where. And this gives me some insight, but this is also a bit more challenging, since the error then is usually a bit more abstracted from what initially caused the issue. So for your case, if you are saving on installation time, I would probably not install this either. And this would be already everything. So let's see. Unfortunately, cannot really nicely show everything on one view that is needed. Though maybe like this. Can I make this bigger? Yeah, I can. Zack. So yeah, this would be the recommended configuration. Though here, I would really probably go just for serial port and just ignore the rest. But for this case, just go with everything. Okay, next, then again they ask you for the license agreement. Actually, there are a few, and they start with the GPL one, but there should be a LGPL somewhere in the list as well. You continue, and the next, and one more next, and then it will install it. And this will run for quite some time. So, like every good cook, I already pre-baked the Qt before the lecture. I have it installed here. It's the version 6.8. And we can start working from here. So first we will close the Visual Studio that we had opened from today morning. And what we'll need next is the necessary plugin. So we can just search for it on Google, not on Bing. The annoying thing with using virtual machines is that they always come not set up the way you want them, unless you always keep a nice up-to-date image, which again adds additional work. So usually, if it's not so critical, people don't do that. Qt. Then we of course need to pick the version which matches our Visual Studio installation. Yeah. So in this case, since the only version of Visual Studio that you can easily download from Microsoft is the current version, so 2022, we will get the plugin for that. Is it the right download? No, it's not the right download. It's just a Qt page. Then it's here. Yeah. And if you have an older version, you can select different plugins here. Also, if you would be using one of these modern ARM based Windows devices, there is a separate plugin for that, for the ARM version. But I guess you're probably not, since those devices are still quite rare. So this downloads a Visual Studio extension file, which we can then just double click to install. Zack, zack. Install. Yeah, in tasks. Some components of Visual Studio were not closed yet. And while this installs to the modus of this lecture exercise thingy, you will get homeworks assigned, which you have to accomplish within 2 lectures from when they have been assigned. If they're like in 2 weeks from whenever they are assigned, except if there are holidays, then it gets extended. And in principle, late submissions are perfectly fine as long as we have not reviewed one of the solutions during the lecture. So if you submit them within the first 2 lectures, it's safe. If you want to submit it late, it's always at your own risk that if it will be shown, then you might not be able to submit it, even though you were quite almost done with it. What you can do is you can submit it like a rough version and then a final version if you need more time for that. The submissions will not be graded in real time. You will get only grading at the end of the lecture. The main reason is when you are programming, it is important to be able to find your own bugs, so test your own code. And when you are convinced that it is working as expected, then upload it. At the end of the lecture, there will be a final project. It will be scheduled about a month before the end of the lecture, and after this there will be no other homeworks. The final project will count about 50% of the points. So if you feel particularly courageous and particularly lazy, you could go for only submitting a very good final project, and you will still get a positive grade. But I don't recommend it, because obviously you probably want to get a very good, and for a very good you should submit at least most of the homeworks. The homeworks will usually contain an optional component which gives you extra points, which is helpful in case some of the other submissions were faulty, or just you don't did them in time. That can also happen. So this much about that. You can ask me, yes? Yes, and then the points are counted together at the end of the lecture, and basically the normal 100 points is if you would get 100 points at every exercise. So for example, if you get 10 exercises, and in every of the and you only make 9 of them, but you make the extra points for each of them, or technically you may have even 150 extra points. So if you do that, then you still have more points than would be the maximum needed for a very good. So the idea simply is that it allows you to accumulate extra credit to compensate for either screwing something up or just not having time to do one of the assignments. You're welcome. Yes? You don't need to have completed the first part, as long as you have some prior knowledge of C++. Mm-hmm. Mm-hmm. You can use Linux and Mac with the Qt Creator. So when you are installing Qt, just install Qt Creator and use it. Which one is easier to set up? That's a good question. The last time I set this up on Mac, that was probably 10 years ago in a virtual machine. So back then, I think it was not terrible, but there were a few annoying things you needed to deal with in order to get your projects to run. On Linux, it was mostly an out-of-the-box experience, but that was 10 years ago, and they certainly improved a lot with regard to the user friendliness. So I would recommend, if you prefer the Mac overall, just try installing Qt Creator and see how easily you can get some Hello World application to compile and run. And if it works, great. If it doesn't work, then you can try it on the Linux system. What you also could try is, if you have Windows 11 in a virtual machine on the Mac, you can just install Visual Studio into this. So a lot of people that use Macs that I know, they have Parallels or something comparable installed, simply because the software catalog for Mac is still limited in comparison to the one for Windows. There is one caveat. Generally, when working with Visual Studio, you get these Visual Studio project files, which are extended with some additional attributes for Qt. And if you work with the Qt Creator, you get Pro files, which are much simpler text files, which contain a description of your project. So basically a list which source files to compile, compiler settings, stuff like that. And while Visual Studio offers you the option to import such profiles, as well as save a existing project as a file-based project, first of all, it does not always work perfectly, and secondly, this only works kind of from the Visual Studio plugin outwards. You cannot use Qt Creator and tell it to save it in the Visual Studio format. And since here I would use Visual Studio, then I would usually create those Visual Studio files, and you might not be able to run them instantly on your system. It will need some manual adaptations to get the projects that I will upload the Moodle to compile on using Qt Creator. The other way around, so your submissions, this is not a problem. You can submit them as Qt Creator type projects. I can easily import them in my Visual Studio to run them and check if they are doing what they're supposed to do. Any more questions? Yes. Everything's online. What stuff? Oh, they must have added this like by default, I guess. I don't remember setting that anywhere. Although technically you can just, if they are publicly available computers maybe in the library, then you could sit there and use them, I guess. Good. So, any more questions? Okay, no more questions. Then let's continue. So, we have our Visual, so the installation here finished. Then we just start Visual Studio. And first we will choose the option continue without code, because we want to access a few more settings. Here it already throws a few warnings. One, that you don't have a Qt version set up, that we will need to do right now. That it was installed, this is fine. Obviously it was. And this we don't care for either. So now this, you might remove it without thinking and then wonder how to do it. Then we can, so we will do that as well. You just go to extensions, Qt tools, and then Qt versions, and then you can set it up. The other way to get there is nowadays through options, and you have a huge list, and one of them is this Qt. In the older versions of this plugin, they had much more custom dialogues, but that all was removed. And here in the standard dialog, we just click on add. This gives us an empty entry. Then we select here this browse button, and then we just go to the location where we have installed RQT. So in this case, you see I also have some ARM binaries, but we will not be using them. Here we only want this folder where the QMake is present, and then it automatically detects the type and the version, so this doesn't need any changes. We just press on OK, and at this point we are ready to create a first Qt project. So we can go a new project, and in this view you basically have all the different projects that Visual Studio supports, and nicely Qt projects, since they're new, have been listed at the very beginning. We can of course filter them a bit more, like we just want C++ and Windows, then and project type Qt. So we can even restrict the list just to the Qt project. And there are quite a few different things that you can create, but for our purposes there are only 3 types which are really relevant. A Qt console application, which is just a UI-less text-based Qt application. Qt offers a lot of nice functionality that also allows you to create applications without a graphical UI. If you want to write something that passes some data files or something very quickly, you don't need to make a graphical application for that. You can just create a text-based application. But generally speaking, nowadays with the latest additions to the C++ standard in the standard template library, you could do many things by now, also just using standard C features. You would not need Qt. About 10-ish years ago, when C++ was not that flexible, so the standard template library was much more limited. Qt was, in this case, even more important because it allowed you to easily create quite advanced text applications. The other type of applications we are, of course, mostly interested in are ones with a UI. So, Qt widget application. There are, in fact, 2 types. You have Qt quick application, which is kind of the modern type of application, but this is a bit more cumbersome to make a UI. You can make a UI that looks very modern with transitions and everything that modern users might expect, but at the cost of putting much more work in getting the data on the screen that you want. The Qt widget approach allows you to make old school UIs, as you know from before Windows 8, where was a thing. But this still looks reasonably very good, I would even say, on modern systems, and it provides a much higher information density, and it's much more user-friendly to quickly create even very advanced and very complex UIs. So we will use only this type for graphical applications. And the last thing that might be interested is a class library, which is basically just a DLL. Although generally speaking, we don't need to use this wizard here. We could just create a normal DLL and then just enable some Qt features. But those 3 types are the ones which we'll be using. And for starters, we just start with a text-based application, so we can give it a name. Let's say Qt Core Test, and create. Then we get a custom window in which we can select which Qt version we want to use. Here we'll use a debug version, although this can be switched later very easily. And yeah, you can also select there is a newer version, the CMake project type. I have not used that in Visual Studio currently, but that would in fact be more compatible with using Qt Creator. So, but since I haven't tried it out, I prefer to stick with this one so that it definitely works and we don't have any other problems to debug. And one more thing you can enable is this PCH. This stands for precompiled header. The idea is that most of your includes, of the Qt includes, will be located in only one file, and thus only compiled once, which improves the compile time significantly. So we will select this as well. Then we can press finish. And voila, we have our first Qt application. It doesn't do much, it just starts and does nothing, but it's a good starting point to start doing something with it. So one thing we notice here is that it creates this Qt Core application object, which will implement a event loop for the main thread. And if you are creating a application, so a graphical application would be just Q application, not Q Core application. And Q application is derived from Q Core, so it just extends it with additional functionality. The application object is quite nice to have because it offers you many convenience functions like, oh, does this work? Visual Studio should show you the objects available, but apparently it hasn't loaded all the IntelliSense stuff. So what we can look for, we can just Google it. No, we won't Google thing. And there is a list of all the Qt classes. I will put the link into the chat. Where is the chat window? Zack. The core modules, and here you have a list of quite many things that you can use in Qt. It's quite useful, and there is a second list with all classes. Was there, or did they split this? In the past they had a documentation link with all of the classes in one view, but apparently they have split it, so now you can only view a portion of it, which is not that bad, since that was really a huge amount of classes that you had in the past. Let's see if we can find this, if they also have somewhere this all classes link that was convenient. Just Qt all classes. There it is. That's the full list of all the classes the framework offers. So I'll put this link as well in the chat. In general, it is quite useful to just reference this documentation whenever you are looking for some details. So in this case, Qt core application, we see what it has and how it is made. It is inherited by Qt Android service, Qt GUI application, and probably a few more other ones. Here we have most of the functions, so we can easily get the current application directory, the file name, name of the application, the process ID, version even. So a lot of things which might not always be straightforward to retrieve. For example, on Windows, if you want to know the folder from which your application was started, you need to resolve first the module name of your main executable, and then pass it to get the folder from the full name and stuff like that. Here, those things are offered as convenience features and many other things. So you can also take a look on the Qt GUI application, from which the Qt application is derived. So the Qt GUI application is like a common base used by the Qt Quick application and the all the Qt widget style applications, and the just Qt applications stems from the time where you didn't have this other type. You did everything just with either core or just Qt application, and it adds quite a few more UI related features like access to the clipboard, the path to your local desktop and stuff like that. You can get a list of windows, so many things that you might want to do, you can do with that already. But as I said, for starters, we will just use the non-graphical version. And one of the main features of Qt, and what makes it such a convenient framework, is that you can easily connect different objects with each other in a way that C++ as such does not foresee as being a thing that you are supposed to be able to do. So this mechanism is called signals and slots, and we can implement a test case for that. So add new item, new class. It's my class 1. We can derive it from QObject. QObject is a standard class provided by Qt, from which almost all other Qt objects are derived, and it provides the basic subset of functionality that is necessary. There are a few classes which are not. A prominent example would be, I think, the string class, and I think the QVariant as well. But most of the other classes are, in fact, derived from objects. And have all the nice functionality that Qt implements. So we have created one class, and okay, this is of course also a bit not nice. Technically, we should have this include already now, precompiled header. Okay, that the machine actually screwed up. The precompiled header should not reference itself. Do we have any includes on many Qt core Qt application? We can move this here already, and this will automatically include like Qt object and other things. So this then should be fine. And of course, it's important that our precompiled header is always the first include in every file, but this the automatism did correctly. And for Qt to work, we need to insert here a preprocessor definition, QObject. This, when we follow it, implements a few things that need to be implemented on every object that should express this QObject behavior. Qt does a lot of things with preprocessor definitions. So we will create a standard constructor. This customer for these things to have a to take a pointer to a parent object. So one of the mechanisms that QObject implements is that you can have a parent-child relationship between your objects. So if you have a class which has pointers to other classes, if you know that those other classes are only valid and should only exist in the as long as the parent class exists. In this case, it's not a parent class; it's more a owner class. So in C++, when you derive one class from another, the one is called the parent, the other one, the derived one, is called the child, and the child has all the properties of the parent plus new properties. The parent thing in Qt is something completely different. Here you have classes which are from each other independent, except that a class which has some member variables, those member variables can be pointers to arbitrary other QObject derived classes, and then this class can set itself as a parent of sorts, such that if you delete the parent class, all the child classes will be deleted as well. So it helps you with memory management quite a lot, and there are a few other mechanisms which we'll also take a look at. We will not implement a destructor here, we don't need that. But this needs to be completed. So we just relay the parent to the QObject. And of course you can change this parent. So you can create a class and then you can assign it another parent, or assign it no parent if you want it not to be deleted when something else goes out of scope. When creating such classes, it's also quite common that at least some of your objects will have no parent, etc. So this we will all investigate in due time in detail. But for now, let's continue with our sample case. So let's create a signal. In principle, it is a function with usually a void return value, so it doesn't return anything, but you can give it mostly whatever arguments you want. In special cases, it might complain that a particular type is not yet registered, where in this case you would need to register it, although with the newer versions of Qt this is much more rarely an issue. With the older Qt it was much more picky with which types it accepted, but here let's add something like, for example, like const qstring reference 1 and that's it. And now usually you would create a second class so we can do that. For simplicity we can just copy this, what we have just created. We just will then change the names, and of course we save it. Zack, Qt test, Qt core. Could also of course use the wizard, but as you have seen, we had to add a few things, so I think it's more convenient to just copy the things. Okay. Add existing items, that number 2. Age to my class 2. Replace all. Here the same thing, age. Okay. And there's one thing that will change here is that here we will want to have a public slot. My slot 1. Public slots. And the way this in fact works is this slot keyword is just an empty, so it's a preprocessor definition to another preprocessor definition, which at some point just is nothing. It's empty, does not contain any content. But it's important in as far as Qt runs an own meta object compiler over the code and extracts and looks for these keywords, for example, and then knows that the things that have been defined after public slots before another access keyword like protected. So everything public slots or private slots or something are basically function calls, normal ones that you can call, but there will be added a mechanism to access them through the signal and slots system. Similarly like with signal. So normally when you create a function, you need to give it a body, which here we in fact have to do, otherwise it would not compile. But for the signal we don't. So the signal here is a function, and the Qt meta object compiler will create a body for that function completely automatically. So we are not supposed to write anything for it. It is just the definition itself that we have to create. Okay, so we have these two classes. We can maybe add a few more things. We can include QDebug. It allows us to print debug messages, and here we can, for example, print QDebug. This QDebug works like stdout mostly. Not stdout, cout. It's called in this. So standard template library is cout. Just that I don't think you have so much formatting liberty. It will generally just create one line of text, and it will automatically insert spaces between those shift operators. So it will like something and then the text that we pass to it. This is and we can put a breakpoint also here, so that we can then see how this mechanism worked in practice. So we go to main. We will now include the needed headers, my class 1 and 2. Then we will instantiate those classes. One, class 2. We can instantiate them on the stack, so this is fine. This does not. This will work just fine. And then we need to connect the signal with the slot somehow. And the nice thing about this mechanism is that normally in C and C++, if you are trying to somehow connect things to each other, they need to be somehow prepared for that, have some awareness of each other for it to work. You can of course try to generalize things manually, but this is work which here at this meta object compiler and the Qt framework completely takes away from you. So we use the QObject connect function. This function is static, so we can call it on the QObject directly. Somewhere here it's defined, static inline connect. And if we would be inside something that is already derived, for example here, since this itself is derived from QObject, you can just write connect and nothing additional is needed. But here it is. So first we have the sender, so which class sends. I think it was class 1, and this needs to be a pointer, so we take a reference on it. And there are now two ways how this connection can be done. The old school way, how it was always done in Qt, at least since Qt, well, I know it's since Qt 3, I don't know how they did it earlier, but I guess it was very similar. Or a new way, which has been introduced with Qt 5, and especially is prominent with Qt 6, where you can use the modern language features of C++ 11, things that have not been available in the past. So for starters, we'll just go with the old school method, and then we can try the new one just for fancy. So we write signal and open brackets, and then we just write the name of the signal that has been defined here with the arguments. So class 1. But with the arguments, but without the names. So signal, my signal, const, like this, comma. Then we can specify a receiver. So what will be called? It will be and class 2, comma slot, and class 2. Again, the same approach. We need to specify the argument list, but we don't need to specify the names of the arguments. And in principle, if we would have a function, so the function here must of course fully represent what we want to connect to, but we could create a slot which has less arguments than the signal, and this is valid. It should not have different arguments than the signal, or it should not have more arguments than the signal, but less arguments. Okay, the excess arguments would be just dropped, which in many cases is a useful thing to do, because for example many of the signals that the Qt UI objects emit are a bit verbose, so they contain various additional informations which you might not need in most cases when you are using them. So then it saves you from creating your functions with an argument which is then not used. So it's a minor optimization, but it is quite okay. Yeah, and what we also will of course need is something to do it. So we can, for example, go to class 2, it was ascending class, and we will give it something that it will be able to do on a timer, for example. So class 2 we have here int timer id. For starters we give it 0. We also need a void. That doesn't work. Time event. Unfortunately, for some reason the IntelliSense still doesn't seem to have indexed everything. No, it does. Time event. Yeah, that's the most convenient way. You just go to the definition and copy the right definition directly. Override. That's not how we write it. Override. Yeah. So the override keyword just specifies that this must be a virtual function, and we want to override it. So if you would have a virtual function and you try to if you would have a non-virtual function or even no function, you try to override it, then you might find yourself in a situation that you think it will do what you want, but in reality the function doesn't exist and won't have any effect. But if you specify this override keyword, it will demand that this thing must be defined as a virtual function on the parent object. Okay, so we have our timer. Let's wait. That's the one with the slots, sorry. Then we want to make this on the one with the signal, this one. So we take our function, class 1. So this function will be called every time the timer elapses. The override is not used in the C file, only in the header file. And we should add a destructor here actually, because it's good practice to delete the timer. The destructor, when we see here, is already defined as virtual, so we don't need to redefine it here a second time. Okay, so timer id is equals start timer, capital T, and we can specify an interval, let's say 100 milliseconds, and to dispose of it, if timer id, then timer id, and then this will call this so often. So obviously we might, why not? But let's make this 1 second so we don't spam the log with too many results, and we can check if actually we get the right. So we could in principle start multiple timers, and then we should here check which timer we have started. So for example, if event timer id is not equals our timer id, then we just call the original function timer event and return. Especially with graphical applications, this might be good practice, since if you have some object which is derived from something else. It might create an own timer for some animation purpose or something, and then you of course want to ensure that you will only trigger on your own timer events. And here we make emit my signal 1 with some text, say test. My signal, I didn't call it 1, I called it slot 1. So let's make it also signal 1, and then we need to fix this here. Signal 1, slot 1. And emit is again just a non-keyword, it's just an empty thing. The whole idea is that you just use it to mark that you are calling this, that you are emitting a signal. It makes the code more readable, but in fact the meta-object compiler doesn't even care for that, since all its magic happens directly here in this function which it implements for us. This is here quite simple. And one thing to keep in mind, of course, is that this timer, it runs and operates in the context of the thread to which the current object belongs to. So when we start such a timer in our main thread, if you would add here, so at this point the timer is already running, but if we would add a huge amount of work so that it waits or something, the timer would not trigger even a single time, because the control flow of our main thread would never reach an event loop. Only once app_exec is invoked, then the event loop for this thread starts. We'll also then take a look on creating our own threads with Qt, where we can create our own event loops and things like that. So let's run it. Okay, let's wait a second, literally, and voila, we are in our slot. And when we now go to the call stack, we can trace it. So let's see, somewhere main, it was our application. App_exec invokes the event loop. The event loop does its thing. It uses some Windows internal functions. For us, this is completely opaque, basically, because if you would be on Mac, then you would just use some Mac internals, or on Linux, some Linux internals. Everything here is just fully abstracted, and then for us it behaves just as we want it. So let's see where does our application actually re-enters. Here in our timer, it makes the emit. The emit then still says that it goes to our application, but this code here, this mock mycpp1 class, as you might remember, I didn't wrote that. This was fully created by the meta-object compiler. A similar file was created also for the myclass too, and it contains various setup code, as well as here for every signal that was implemented, the signal as such. And you might also notice here that the signals internally are just identified by number, so it just numbers the signals 0 through however many you have, and that's it. Yeah, and then of course at some point we reach the Qt internals. In this case we can, I think I added the debug information, so we can see the internal implementation. So inside Qt object, makes this to activate, which then does something else, which internally then at some point will call our own function. So here it calls already a function that was implemented now for class 2, and then this wrapper function, this dispatch function, will call based on the ID of the signal or slot. In this case both are 0, but of course just because they are 1 in each. If you would have multiple signals, then in this case here, then in the other one would have still 0 on the emission, while this one would have a non-zero on the slot, or the other way around, or both would be non-zero if we just don't select the first ones, etc. And then this of course then calls our actual function, which then has its argument and can do everything with it. One thing noticed here is that everything happens inside one thread. So if you so in principle you could, if this would not be const, we could have modified argument 1 and return it this way. So we could have gained the ability to return values. This mechanism, however, needs to be used carefully, because if the two objects reside in different threads, then it will not be such a direct call as we see here, but the data will be queued on the queue of the other thread and then invoked from there. And in fact, when connecting, we can even specify how we want this connection to work. So connect, comma. We have here this connection type, which by default stands on auto connect. But when we go to the definition, we see that we have quite a few more. So auto connect is obviously the default one. Then it picks whichever connection method is the right one based on the thread relation of the two objects to each other. Direct connection is what we have seen here. So when both are in the same thread, then a direct connection can be made, which is much less CPU intensive and resource intensive than other types of connections, but of course has the downside that it locks the other thread up. So if we would have two threads that are independent, then one thread could emit a lot of events and the other one would process them in its own time without blocking the previous thread. In which case, obviously, we could not pass anything as reference. We would need to always pass it as a full copy. Otherwise, once the data in the other thread go out of scope, and yet another thread finds it's time to process the events, it might then try to access invalid memory. So that behavior would be this queued connection, so where it just puts all the data on a queue of the other thread, and the other thread does it in its own time. But there is also this blocked queued connection, which in fact would be again suitable to get some data back from a different thread, because while we emit a signal, the function that emitted the signal will wait until the other thread signalizes back that that all the connected slots have been processed. So this way you can create a nice data exchange between threads and some synchronization. And then there are a few other connections, like unique connection and single shot connection. Single shot, so unique means that you only want to have one connection between a signal and a slot. You don't want like multiple signals, multiple slots on the same signal. Or single shot connection means that the connection will be automatically disconnected when one event has been sent through it. So, for example, when we run it like we had it, remove this. This will each time trigger the function. If we would have set it to be a single shot, then the connection would be removed after it has been executed. And if we want to manually manage it, we can also use the disconnect function, where we again this one is a bit more flexible. So we can specify a receiver and a name, and then it will disconnect everything from it. We can also specify a signal and the receiver and a member, or we can specify everything: a sender, the signal name, the receiver, and the other member function that is to be invoked, the slot. So it is quite convenient. Whatever we want, we can disconnect things quite easily. And before we take a look on running a second thread, we can also look how this would be done in the more modern way. So we have our class, we have our sender, and then we need the name of our class. This method is a slightly more limited. My signal, and we need the reference because it's not a static function. The nice thing about this is that it checks what you are doing in real time. So if you would make it like this, or L instead of 1, it will bug out. The above case, it will accept any garbage you write here. Just that then when it actually on runtime tries to do it, it will print you a log line that the connection could not be made because the slot wasn't found or something like that. And obviously we always prefer to have compile time errors instead of having runtime errors, because runtime errors, you need to run into them. If you have a large code base when not all code paths are always used, then you might introduce a bug which only will be visible in production in a special case where a exotic code path is taken, or you might just not notice it that the connection has been broken because you are not monitoring the error log, things like that. So this is the more robust option. Then for the other one, of course, we then also need the class name. My slot 1. The nice thing is also that you don't need to type the arguments, and it suggests you the correct name using IntelliSense. So this is quite an improvement. So this works the same. And with these new features of our C11 compiler, we can also do something completely different. We can connect to a lambda function. Zack. Okay, this needs an argument. Const string reference test. Let's go to okay, this we can close, this we can close, this we can close. Here, let's copy this line. We will just change it. I had to call it arg1, not test, then we should stick with it. Actually, we can leave both connections since we don't have here exclusive connections specified. We can connect as many slots to a signal as we want. In principle, we can also connect as many signals to one slot as we want. But this is something we'll take a look on later. So when we run it, you see each time the timer triggers, both slots are invoked at the same time, or rather very closely to each other. And as we see, always in the same order. So in the order the connect was made, the slots are listed inside the internal object such that this order will be maintained. But this is not something I would relay necessarily on, so that it always will behave like that. If you can delete it, so disconnect it and reconnect it, then the order would change and things like that. Another thing about this mechanism is that you can also specify it like that. You can add an object and then your lambda, and this works pretty much identically. The only difference really is that in this case, this lambda and this connection live at least, well, not quite forever, but at least as long as class 1 exists. If class 1 goes away, then this thing would also go away. But for example, if you want to here interact with some objects, then you would want a way to either hold on to them, or you'd want a way to ensure that if those objects were to go out of scope, that then your lambda would no longer be triggered. So for example, if we would want to, let's say the function our class 2, void I don't know, my test, which also takes arg1, which will be pretty much a copy of this, just printing a different text, and then we want to and then we would want to access. So since we have here a capture everything, we could actually don't do that. This would also work, but we can, for example, capture only class 2. Can't we do that? We need to capture it by reference. We don't have a copy constructor for it, so we can capture. So if you are familiar with lambdas in C++, when you define such a lambda function in the square brackets, you define which variables you want to capture and how. And if you just add an end, it means it will pretty much capture the whole local frame, which is a bit excessive. So usually you either capture it by copy, but we don't have a copy constructor, so we cannot, or you just capture by reference, which is the most efficient way of doing it. So here we have a function class 2, my test with arg1, and the thing is that if, so in this case, of course test 2 cannot go out of scope because it's in the stack of the main thread. But if this would be something with a limited lifetime, then this thing could go out of scope, and then since it's still captured by this lambda function, it would cause a crash. But if we specify this object here, then the lifetime of the connection will be limited to the lifetime of this object, so we can avoid the situation that this lambda slot tries to get triggered while the object it relies upon is already out of scope. Now, if you would have, if this thing depends on 2 or 3 objects, then you're out of luck. You cannot add more of them. This only works like for 1, but this usually is already good enough. So here, as you see, it still works as expected. Are there any questions right now? Okay, if there are no questions, then we can continue. So we have seen how this works. here with the different connection types. Then it's time to create an own thread to demonstrate some multi-threading with Qt. So as mentioned, in Qt you have this ownership relationship or parental relationship between objects, but every object can also be associated with a thread, and this is something that will need to be taken into account when creating new threads. So if you generally the way is like this: if you want to have an object in a different thread, then usually you have to create at least 2 classes to achieve this properly. So let's add not the file, let's add the thread. Add the class. Save my thread. Actually, I should call it my thread 1 because we will probably create more of them. Oops, I wanted to call it my thread 1. And that obviously changes the names each time, so this is a bit annoying. Q thread. It will create for us the file. Some things will be missing, as first of all we don't need this. Q thread should also be included, I think, in the standard, although it might not be, so let's include it explicitly. Zack. Right, so we have our thread which doesn't do much, so we should say Q object, because Q thread is obviously also derived from an object, so it belongs itself to another thread, and you should not move the Q thread into itself, so to say. So the Q thread, so every Q thread you create should be owned either by the main thread of the application or by another Q thread. So public my thread 1. Let's be lazy and just copy it from here. So it also needs a parent, but we can keep this empty. We don't need to set a parent necessarily. Okay, and we include it in our main function. My thread 1. Okay, so let's comment this out and this whole thing, and instead this also needs to go. My thread 1. Thread 1, and we need to start it. And when we start it, it will run and then quickly terminate, because it doesn't have anything to do. So the way this is implemented, you have 2 important functions on it. You have the you have many functions, but the most important one is the run function here, which is virtual. The other important function is this exec function, which you can start yourself. I'm not sure if we can not see its implementation yet, so for now let's just implement our own run function. Then we just see what it's doing. I think it was protected, yeah. In principle, it doesn't matter if we could define this as we could define this also as non-protected. This doesn't really matter for us, but for now we will want to do it like this. Rot override, and now we can just call either the run of the parent class to see what its default implementation is, but what we will later want to do is we want to call the exec function. But for now let's run and see where we go. So we have 2 threads running. We can inspect the application, although we will see a bit more threads. So we have here our which one is which? That's our main thread, so it has our main function, and it's waiting in the Q application exec. event loop. Then we have two other threads which have been created during process creation by the DLL to facilitate asynchronous loading of dependencies. Those threads will be automatically terminated at some point, and we don't really care for them. And here we have our customly created thread. As everything, it starts its existence in the NTDLL, and then here it starts in the entry point in the Qt library, and at some point we'll have our code. So here we have our run function, which we can now inspect what it would do. And we see natively the normal Q thread will just run its own exec function, so start its own event loop such that it is ready to receive events. If you would want to have a worker thread which does not need to process any own slots, then you could create a thread and just write some code in the run function and terminate when you are done with doing whatever you are doing. So you don't need to use this exec function. What we, however, will want to do in this case here is we want to create a few objects in this thread. So we can, for example, include my class 2. In principle, actually, we don't even need to comment those things out because we will just get things doubly and triply printed into the console from the other thread. But for now, let's keep that commented out. So my thread, we have already protected, so it's my class 2. So we have two things. We can either include the header already here, or we just tell the thing that it's a class, and as long as we use pointer types, this will be flexible enough. So my class 2, pair my 2 is like null ptr. Okay. And here we can now instantiate it. My class 2, and since we are running already in the other thread, the class should be created and belong to this thread. And once we are done, we can delete it, and we should delete it. Since the thread itself belongs, so the thread object itself belongs to another thread, so we cannot use this ownership mechanism here. But what we can do to avoid the need to delete those things manually, well, there are a few things. This approach is quite simple and quite useful because it doesn't need a lot of mechanisms. If we would make this into a smart pointer, then it would only be deleted once the thread goes out of scope. But since we created this in the context of this thread, we would also want to get rid of it in this thread. So first of all, we don't need this globally. We can instead either just define it locally here, since we have our run and everything, or if we want to make it more efficient, pointer, oops, and this thing is a smart pointer which will keep the reference to our object alive for as long as this object or a copy of it exists. So in this case, once this terminates, the object will be automatically deleted. So if you cannot use this child-parent relationship, you can use this mechanism instead. Okay, so we have created our class 2 object, and what we will need is some way to connect them to each other. So one approach would be, for example, to set main function to set a variable on our thread that will now call connect and so on. This would be one option, but this would of course require our thread to have awareness of the other thing. So if you want a mechanism that works with let's say less awareness, then what we can do is we can go back to the previous version of the code but change it slightly. We move the creation of the thing here, but here in this constructor we are still inside the main application thread, so we need to move to thread this, oops, And once we've done this, this object will be created and it will be associated with this thread. This thread will then handle it and dispose of it once it has terminated. We can set it to null to ensure we don't have any dangling pointers. And what we also can do is we can add a destructor. So obviously when we run a thread, the object that manages it might get out of scope, so we don't want that. We make wait, and without specifying for how long, it will just wait forever. So now we have ensured that the destructor will only then release once this thread finishes. And what we also can do, we can make a call the quit function, which will tell this event loop that it should terminate once it's done doing its thing. Then once it terminated, it will dispose of those things, and then this thing will terminate it. And a good practice would be also to check whether it's actually running. So if is running, then we do this, and else. So if it's not running, it might be that we have created it but we never stopped it, then this will never be called. So in the else case, we delete the thing ourselves. So I guess we should move it back to ourselves. Move to thread, current thread, stack. Okay, and if we make it like this, we can have a function which gives us a pointer out. Get oops, wrong place. Get my class. Ideally, we would want to add some more synchronization here, but we want to do that just to keep the example reasonably simple. So we can continue. Actually, we can just change this to a pointer. Pay class. Move the thread upwards. And this is then, and we don't want to start it yet. We want to start it once we are done. Although it kind of doesn't matter. The connect process itself is thread safe. Get my class 2. So now of course we don't need the thing. This can be then passed by value. Okay, and let's run. I think we forgot something. This tool here, when it still keeps a lock on the recently inspected application, it does not closes the PDB file. Then you just need to deselect it and wait and retry a few times. Okay, so we are here. We don't care for that. And as you see, it is still working, although well, it looks the same. So we can add some things that will make it more clear how it behaves. So here, for example, we can put a we could for example add the current thread ID to it. Current thread ID, so we can see from which thread those things are called. But of course here, since we have connected it in the context of the other object, we see that it is from the same thread. But we can inspect here that the thread is so what was it? 96C2. 96C2 is our worker thread and not our main thread. We deselect it so that we don't get stuck. So when we now go back to our main and comment out the specification of the object and run it again, now we see that the threads are different. So now this lambda function is executed in the context of the main thread. It still calls this class function on this class here, which might be problematic with regard to thread synchronization. So if we would have stopped this thread at any point, then it would cause here this object to become invalid and then the whole thing to crash. So as you see, this is one of the uses of specifying the object to which the connection should be connected with. And of course we can now investigate this slot here, how it looks, the call stack. So we see here that we start in our run. The run executes the run from thread, which executes exit. We could have here called directly exit, it doesn't make a difference. And then we have the threads event loop, which at some point then calls out to our function, which is then being executed. Okay, so any questions? Okay, so I think it is quite apparent. Where's the stop button? It was stopped already. So I think it is quite apparent that this mechanism is very flexible and very powerful, and a lot of things in Qt use, almost all things in Qt use these mechanisms for communication, since it allows you to create a little bit of a asynchronous behavior inside of your even single-threaded application. So it's quite user-friendly, and as mentioned, we can connect, of course, multiple slots or multiple objects. So for example, we can create yet another class. So let's quickly just copy our class 2, make it a class 3. Add existing item, class 3. Class 2 becomes class 3. Zack. Same thing here. Age. Zack. It even already changed the strings here. So we can just maybe we don't want this to make it too complicated. Oops, just make our, and we need to include it, of course. Class 3, class 3, class 3, class 3, class 3. Wait, that's not right. This one. And this one, signal 1 was it? Yeah. Okay. Yeah. That we need to create a new one for here. New. And what we also need to investigate today is this parent mechanism. So oh, there is a semicolon missing. We don't want breakpoints. So as you see here now, our slot 3 is also invoked. So as said, you can connect as many slots as you want. And what you can do inside a slot is you can get a pointer to the object which emitted the signal. So object. Actually, we know that it was a class 1 that emitted it. So let's include it here. Not say class. My class 1. My class 1. Asterisk. My class 1 is equals Q object cast. It was not capital. Object cast, and then there is a function called sender. The function is defined on the QObject object, and was it? Zack. And it will just return to us the pointer to a QObject which emitted the signal that triggered the current slot. And using this QObject cast, we can safely cast between Qt types. So when we run it, we arrive here and we get our object. We have our timer ID, and the rest of the things is some internal data that we are not very interested in. And if we would if this slot would be invoked from a different source, something we did not expect, so for example, let's say we expect to be called by class 2, which in this case of course makes no sense, but it's something we might maybe expect in some scenario. So even though sender will return a valid pointer, class 2 will be null, because this casting operation here, it's in principle just a template function that then uses some, it calls this static meta object cast, which checks whether the types are compatible, and if they are, it would return a pointer to the type we wanted to cast to. Otherwise it would return, as we see here, null. So if you have Qt objects, using this casting operator is always the safe way, because you will not miscast objects. If you would use a normal cast, you would just force cast things, and then things may start breaking. So we will quickly undo this change. Yeah. So this much discussing, and then of course, since we know who called us, we could somehow interact with that. So for example, since we have here our class 1, we might want to trigger this in some different way. So let's for example, we want to just call it once manually from here. Invoke method, and we want to cast it on this thingy, comma, then we need to specify the name, and the name we specify just as a string. So we want it on class 3. Let's say we want it must be a slot, so my slot 1. And then, depending whether we expect a return argument or not, we could specify it here. Since we don't have a return argument, we just proceed to our string qarg qstring, comma, and then well, we can specify qstring like test123, and we could specify as many as we need. So it's a variable argument function. But since we only have the one, and at some point we could also specify the connect type. So yeah, after the member. So if we want, then we can specify here the connect type, which is Qt connection type. Let's go with Qt connection. So even though we are in the same thread, let's say we want this call to, so this will run over it instantly, and once we arrive in the event loop, yeah, class 3 is defined on our own, then this will be executed. And as said, to call functions this way, we could also explicitly specify a return parameter. Or actually, why not make it slot 2? Let's add a second slot to our class 3. Slot 2, zack, 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 slot 2. And we'll notice here that in this scenario there will be no sender. So sender will be null, because it was invoked, so here it's null, because it was invoked manually. And oh, we did not change the name here. Let's quickly fix that and run it. Right, so here we have our slot 2 call, which was almost instant since we didn't wait for a timer to finish. And this mechanism can also be used for synchronizing and communicating between threads. So you just need a pointer to the object. Of course, need to make sure that while you are doing this, that this thing will not go out of scope. But other than that, you don't need any additional synchronization primitives. And Using this with direct connect is of course a bit pointless, because direct connect is as if you would call it directly, you don't get any synchronization. But queued connection or queued blocking connection would be the exact right thing that we would want in such a scenario. And I think the last thing here to play with will be the inheritance mechanism. So let's create yet another class. For okay, let's say we want to get rid of this thing at some point. So qtimer, okay, that's also not defined. qtimer single shot. Duration, let's say after 3 seconds. And then we can either specify an object and a slot, or we can specify a lambda function or an object and a lambda function. So here we are again flexible. Let's go with a lambda function. It will take a pointer to this thingy. No arguments. Zack. And here it will delete later this object. So this should go out of scope. We can before we include the other things, add the destructor so that we see that that actually works. Although this delete later, as the name suggests, is not quite instant. The idea is that you can schedule an object to be deleted in its own thread properly, instead of having to care for that yourself. Right, so we have this thingy. We will invoke a method on it. We have connected, so it will print the first 3 messages, or maybe 4, depending on how the time aligns before it gets destroyed, and then it should get deleted, and automatically the slot should be disconnected. So 1, 2. Now we get our delete later event. We see here that this happened from the main class, since the thing lives in main. If it would be living in a thread, then it would be differently. And now we only get the 2 things printed. We could in principle move this thing, move to thread, to a new thread, thread 1. That needs to be a pointer. And now, did I remove the breakpoint? We will see. I did not. Right, and now we see that here, now we end up in this destructor is called by our worker thread. So everything works nicely, and as you see also it remains secure. And since we are already so far, it's the perfect place to make a demonstration of the dangers of not specifying the right object. So here we changed it to use this. So this will work, and then we'll remove the object binding. And once we do that, it will it will initially work, and then it should crash. It does not crash. Has it been deleted? It doesn't seem to have been deleted. Let's see. It might also be that the lifetime of the object is being kept. The object is being kept artificially alive. Now we have this. Well, the objects seem to still exist in memory, even though we have called the destructor. Sure. Locals, this. Go to the memory of this. As you see, so we are not using anything from the current object. So even though the object has been deleted and the debugger filled its memory with these, we actually don't trigger a crash because we don't use anything from it. So in fact it behaves as expected, just that the test case is too simple to actually crash. So let's do it. Let's add here, let's say, a value 1 2 3, which we will then int value, which we'll then want to store somewhere, int value, so that we will have a nice crash when we try it again. Value is equal value, and then we'll say test and thread, and let's say that this one will just print value afterwards instead of the current thread ID. And for this, as said, it will need the value thing to be valid. So we go to main. Alright, I returned this. So first of all, we test the non-crashing case. So the thing does what it's supposed to, and then when it gets out of scope, it does nothing. And now if we remove this thingy, when it goes out of scope, so first it works. Well, it kind of crashed. It gives us bullshit data. It didn't cause a hard crash, but you see that the application is no longer performing the way as it should. So if we would make it more complicated, we would actually generate an actual full crash, but I guess this is good enough for demonstration purposes, so that you can see how these mechanisms behave. And now, since we are already so far, let's add our fourth class, add existing item class 4, zack, age, class 3 becomes class 4, replace all, class 4, age. Okay, and let's go to class 3, and let's add a class semi class 4 and pack pointer. Okay, so we are in my class 3, but there is a caveat. So we move this to the thread that might be undefined behavior. Let's just try it out. So what we want to do is we want to create a new object, say that this is its parent. We need to include my class 4 here so that we can work with it. And we'll add a line printing that we reached the destructors. This is the my class 3 destructor, and my class 4 is missing a destructor, so let's copy a bit more. Of course, this needs to be 4 now, and here as well, and there, and there, and there. My class 4 destructor. So now we'll see the destructions happening. Just one thing that might be the comma is missing. Slightly annoying is after we move here class 3, it's interesting to see what happens with class 4, which also had an ability to retrieve it. So class 4, get my class 4, return my class 4, okay, we add main, we add our main class 4 definition here as well. So we have here, we want to get the my class 4, which we have created in the other thread, sorry, in the other class. Get my class 4 and qfog my class 4 my class 4 thread where do I find the my class, it current thread is a current thread. That's not what we want. We want the thread ID. Current thread ID will be a const function. Ah, no, it's not. It's Windows handle. Okay, that's good enough. And we should cast this to a in64. Then we make the assignment and then we check it again to see whether it was moved or not. Yeah, if the type is not defined, we need to say that what we expect it to be at least. So we see that the thread itself has not been changed. So this approach, the simple approach, moving a class once its children have been created, is not ideal. So we can here again print also the class 3. The class 3 thread, which should change. Zack. Wait, that didn't work. Class 3. I think this current thread will still not do what we want. Let's just go with the pointer to the thread object. That should be good enough. This will not be a thread ID as we see it in Windows. Yeah, but we see here that actually it worked well. So this move to thread, it has enumerated all the objects that our class 3 owned and changed their affinity to the new thread. If we would have class 3 didn't if we would have not set the parent, then this would have failed. As you see here, the fourth thread was not moved, but since we set the parent, this worked out. And now when we run it, it will of course exist for the first few shots, and then we get the destructor of class 3, and then we also get automatically the destructor of class 4 being called, and we see that it actually is called once this finishes, the destructor of Q object, which then removes all the child objects. So this way we can easily manage the lifetime of these objects, which is quite a convenient thing to do. One thing that one thing that one should not mix is using parent objects and using smart pointers. So here we can change this to a smart pointer. My pointer. My class is equals from new. Okay, so now we have a smart pointer. For the thread we don't care, so here we can we? Not quite. We need to get the raw pointer for disconnect functions. This is a bit annoying. They could have implemented overloaded functions that also take a QShared pointer for this task. And inside our function here, we can also we need to capture it. We can capture as many things as we want. Was it clear? Clear. We can just assign it. There should be a function to clear it as. Oops. There should also be a function. It doesn't want this. We can assign it an empty instance. I thought that would be a clear. We can quickly investigate what functions we have at our disposal on the shared pointer. We have get, we have is null. Okay, we don't have a clear function. So the smart pointer as STL uses it as a. Oh no, we have reset. And we have clear. Why didn't it's weird? This IntelliSense in this case. So IntelliSense is a mechanism in. We need to capture it by reference. That works. The IntelliSense here is a bit spotty sometimes. No, it works. but once it works, it works. So here our timer, we could, of course could have just two timers. What it will do, it will clear this, so then this object will also go out of scope, but this object lives in the main thread. We can also add a destructor to it. We already have one. Yeah, for the timer, so we just add a print message to it. And the thing is, I said you should not mix smart pointers with the normal ownership mechanism, because then both things will try to delete it. So when you have the smart pointer and the last smart pointer goes out of scope, it will try to delete the object, but the object will, well, it will delete it, while the object will remain in the list, in the child list of the parent object, which is usually not great, because then you have a dangling reference. And the other way around it could also happen, that the parent object goes out of scope, it deletes the child object, and the smart pointers still keep a reference. In case of Qt here, if I recall correctly, they should warn you if you try to do such a thing, so we could try it. But here we don't have any other objects. We can just create a dummy object for that. Q object, pair object is like new Q object. It doesn't need to be one that we have derived from something and created. Just can be any. And it should, I think, it is actually not complaining. That is annoying. Did print an error message? And it neither. I know in earlier versions it was actually complaining about this. Although now that I think about it, maybe they have actually fixed that, so that this does not longer happen. Let's try it out. Per object. Children auto list. Let's see if it was cleared from the parents list. In the old Qt, it always asserted an error if you try to do this. It removed it. They improved the behavior. This is nice. So apparently with the latest Qt version, you in fact can mix this. So if you would have like a list 1 and list 2 before we clear the pointer, the thing should in the first list. Yeah, it is in the first list and it is not longer in the second. So this actually has been improved. This is quite nice. But of course, still, even if you have a even if they fix this, if you would then have some non-smart references to this thing, you might get in trouble. We can also test the other scenario. If we reset it, no, if we not reset it, if we delete this thing, if the pointer will then still remain valid. So by reference, and we will delete it instantly. We will not delete later. And then we will see what this thing has to tell, if it will be smart enough to have resetted it, or if it will then potentially run into a problem. So this thingy, okay, this will be a problem because it says is null false, and then here the things are invalid. So they, and now we also get the crash. So they have fixed it. If you have some smart pointers to something that is a parent, when you delete it, or rather when the smart pointers go out of scope, it will be properly unlisted from the parent. But if you have the opposite scenario, when the parent goes out of scope, unfortunately the smart pointer will not be notified, and the whole purpose of using a smart pointer will be subverted. So even though they improved it slightly, you should not do it. Unless you really certainly know that the smart pointer will, or any of its copies will live shorter than your parent object. But generally, since this is kind of a subversion of how you are supposed to use smart pointers, I would recommend in this case to also just add a smart pointer to the thing in your class, and then you will have the same behavior that will delete the object once the parent goes out of scope, except then if something else holds a reference, in which case it will then be only deleted once the last reference got out of scope. So how smart pointers worked, that was explained in the part 1 of the lecture, so you can review the recordings of that if you are interested, but just generally saying, the idea is that you can delegate the reference counting and deletion of your objects to the smart pointer mechanism. So you can just copy the pointers and do whatever you want, and once the last one goes out of scope, then here the whole thing gets deleted. Okay, so we have seen how to create threads in Qt. We have seen this inheritance mechanism, which is an essential part of Qt. During the next lecture, we will create a demo application to inspect how we can create a simple UI. So we will create some very basic control elements, a window and stuff like that, a few buttons, connect them with signal and slots. So the UI extremely heavily uses these mechanisms. As said, when writing just backend applications that don't have a UI, you can use those things and they are quite useful, but there is much less necessity to use it. So you could create a normal console application without using signals and slots at all if you would really want to. Then of course you would need to use some own synchronization mechanisms. Are there any questions? Okay, so if there are no questions, then let's see what else we can play with. So we could, for example, tell the thread to terminate from our timer here. Of course, need to capture it first. The reference, preferably. Quit, and quit will then just properly. We don't want the breakpoint here. I get rid of it, so it already happened. So when we set again, it does it things a few times, and then when this thing is called, then apparently we have moved everything into the into the thread. So once it quits, here nothing more happens. Though I have noticed that we quit it, but we did not dispose of the objects. There should be a few objects on it. Let's see what went wrong. So we have our thread, we quit it. Oops. Thread 1. Basically, when we quit it, we should run here into basically then the exec loop terminates. Okay, so we have our delete 2. Or didn't we? I think just our to function is missing a destructor. That's why I didn't. Yeah. So let's add a destructor to our to object as well. Zack. 2 and 2, and it will complain until we add it in the header. Whatever reason, it's actually not complaining. But I don't think it's so smart that it knows that we want to add it. It just missed that issue. Okay, so now it should properly show us that it has deleted this object. Zack. But yeah, so dash it did not, because we're still waiting in a breakpoint. Now we let it run. One thing we can here notice is that other things that belonged to this thread, our class 3 and its child, unfortunately did not get deleted. So if we move something into a thread, deleting the thread will unfortunately not dispose of whatever we moved into it. So we would need to do this ourselves. So we can test how this would behave. For example, if you add a delete later on, if it would do something or it would crash. But as we see here, delete later, even when called from a different thread, works. In this case, it kind of knows that the other thread is no longer running, so we can add a breakpoint here to inspect this behavior. So here, as we see, private thread finished. Why are we here? Actually, this should behave differently. 1 second. So we have our thread 1. We have quitted it. Okay, the thing is, the quit is not necessarily instantly. It's still processed. The thing is here. So we could make this wait. Msleep. Let's wait for half a second before we call delete later. Then it will, as expected, not work. Yeah, and as you see here, delete later, even though we called it, it kind of didn't do anything because the thread was no longer running. The reason why it worked before is that while we have queued messages like to delete later and to quit, it first did all the messages still in the loop and then only quit. While here, if we give it time to actually process the quit message, it is not longer capable of executing delete later. And this also, by the way, quite nicely demonstrates the challenges of multi-threaded programming, that the timing behavior becomes a bit unpredictable because the things run in different threads on different CPUs kind of really in parallel, while also might be preempted by other threads, so the timing gets really messy. Right, so this delete later, of course, used this way no longer works, and unfortunately I think there is no really a super nice way how we could get rid of all the objects we might want to get rid of if we quit. So the thread itself, when we review the function that it has, I don't think it has a object list checked of all the children. Yeah, it does not. So if we move to thread manually, then we need to also manually delete later before we quit the thread. After we have quit the thread and we know that it has quit, so we can here also add a wait. So after this was done, then we could just delete this without delete later. We can just, if we would delete it with like this, that would most likely cause a crash somewhere, because we will delete it instantly while the loop, okay, well, but as said, this is something up to the timing. We might run it a few times and sometimes it will work and sometimes it won't. It depends on the timing, but this is not the safe way of doing things. We should always wait to ensure that the delete will not interfere with something the thing wants to do. Generally, demonstrating such race conditions is a bit hard because they sometimes depend on a very particular timing. So you may have a situation where it works in 99 of 100 cases, and in 1 of 100 or 1 of 1,000 crashes, and then you might have a random user where it crashes each time because for whatever reason they have a different timing behavior. For example, much slower CPUs, some much more CPU load, or the opposite, of course. So generally it is simply recommended to be careful when doing such things. There are a few other worth mentioning functions on a thread. You can set the thread priority. So when scheduling the threads, the operating system will take this into account, and threads with higher priority will have always more CPU time than threads with a lower priority. And this can be as excessive as such that threads with a very low priority, you can set it to idle. This means they will only then get CPU time if there is actually spare CPU time. So such threads might not get executed arbitrarily long if the system is busy right now. Another function worth mentioning is terminate. Terminate kills the thread instantly. It is absolutely not recommended to use it because then the thread will not do any cleanup. It won't do anything. It will just die there and then. So I would strictly recommend not to use terminate unless you are very sure that this is safe. So for example, if you would have a thread which just does some computation but doesn't do any resource management, and you have pre-allocated the resources, you let the thread run, it crunches its data, and you know if you kill it, the data will be in an inconsistent state, but since you do the resource management externally, you just then dispose of the data. But if you have something more complex, then terminate is not really recommended. If you really want things to terminate it, especially for example when you are closing your application and you want to avoid a situation where a thread will lock it too long, you could do something like quit, wait for 10 seconds, and wait actually tells you whether it waited successfully or whether it timed out. And then if it timed out, then you make terminate, and the rest of the shutdown of your application can continue. If you crash, then the rest of the shutdown won't continue, but usually if you would freeze forever, that would be worse. So this is the one case where wait and then terminate is reasonable. But of course then you need to implement it such that when you are getting rid of objects, that you tell them if you are shutting down the application or not. If you want the application to keep running, the safer bet is just to keep such a locked up thread indefinitely. Because if you, as said, if you terminate it, it might maneuver safe in a particularly inconsistent state and then cause other problems. Other things that you can do with Qt objects, so well, any of those. Let's go with, for example, our class here, as you can attach properties to them. Set property. Oh, and here of course set parent. You can use to change a parent and reassign it. If you try to do it from a different thread, so basically you can do set parent only from the thread that owns the current object. If you try to do it from a different thread, you will get an error message in the log, and I'm not quite sure if it will actually execute the operation or drop it, but in any case you shouldn't do it, because this parent-child lists which are maintained in the objects, they are not thread safe. So if you do it, you might damage something in the data structures of the parent. But again, since this only this damage can only be temporarily, if you have a race condition, you might run into it. If you are lucky, you might change it and it won't cause a damage, because the inconsistent state is only temporarily. So you should usually refer to documentation. You can set an object of the name even. So let's call it test name. The uses for this are few and far between. Sometimes it's nice, especially for debugging. On the other side, it wastes memory. You can hash if def set those names only if you have a debug build. This preprocessor condition would ensure that this line is not implemented in a release build. You can of course then get the object name with object name, and as said, as mentioned before, you can also set properties. Set property, and the nice thing is that you can set as many as you want, and you can give them as many names as you want. My one map property, and you see that the property is of type qvariant. This is comparably to the qstring, a container class, but while qstring contains just strings, at this point I might add it contains UTF-16 encoded Unicode strings. At least on Windows. I'm not certain if on Linux it would also use UTF-16, or if it would use 32-bit white characters. On Windows it does UTF-16, and it's like an internal representation, so you might not necessarily be supposed to use it directly. A qvariant is different in as far as it can represent a huge list of different types. It can be a string, it can be an integer, it can be a boolean, and a huge list of Qt more Qt specific types. So here let's just assign value 1, but is it complaining about something? It doesn't know what is qvariant. Should tell the doesn't know the type. Oh, maybe we need to include qvariant into our include. So many things are just forward defined. Yeah, no, it's fine. It just was missing the include. That's why it was complaining. And then of course you can get it with property and by name, and you will get this q variant temp. Or let's call it param1 or property one prop1. And then you can cast it to whatever. You can cast it to string, and if it was an integer, it will actually work. If it would be something incompatible, it couldn't do it. But within compatible types, it actually even can do such casts. But obviously, since it was int, we would want an int e prop1. Let's call it variant prop1. And if you don't know what type it is, you could even, so for example, if you would want to, I don't know, convert it to other variants or print it on the console without using toString, you can get type, and this will give you the type of the variant. So we can take, it was the wrong type. There are too many things that are just called type, that's annoying. We can go to the when type is defined here, so it should be somewhere. Yeah, here it is. Is it? Yeah. So these are all the types that the qvariant can represent, including a user type. So you could even register your own types using a special registration mechanism. But the default are like all the machine types, string lists, byte arrays, bit arrays, date, time date. An URL, locate that specifies language settings. Rect is just x and y coordinates in different types of precision. I think rectf is less precise. Same for size. Line, point. So line is basically just a pair of two coordinates, etc., etc. A font, brush, image, polygon, and bitmap. So really many useful things can be represented by a variant. The most worthwhile, except for the typical machine types, is qvariant map and qvariant list. And those actually are just a qlist and a qmap. You also have like a qhash and a qpair defined for variants. So, but those types can be actually held by a variant. So you could make a whole map with variants of maps of variants, etc., and then assign this as a property to something and then retrieve it at any point in time, or with lists. So this mechanism here of attaching arbitrary properties to all the objects is quite useful. In C++, extending objects is only done through inheritance, which is a bit cumbersome because usually you need to create 2 files for that. You could of course just use only the header file, but if you have more logic, then it's less nice. Plus, if the object is then created somewhere outside of your realm of influence, then you cannot have it extended. Other less strict languages like JavaScript or in fact C# even allow you to extend objects externally to the inheritance mechanism. So in C# this is actually quite a neat feature. And in JavaScript this is abused a great amount of time, making debugging sometimes a huge pain. But on the other hand, it is kind of nice sometimes to be able to have an object that was created somewhere and then attach some property to it, so that when you encounter the object in some other place of your code, you can retrieve this property. You cannot attach smart pointers, unfortunately. You could attach a int64, which then is just a pointer, but then you need to manage the lifetime really yourself. So this is something you could do, but it's not really recommended. But for most of the cases where you would want to add some property in, for example, JavaScript, that you could do there easily here in Qt, if you have a QObject, you can also do with the set and get property, and this is convenient enough. What you cannot do as said, you cannot attach a function, extend it with additional functions and things like that. Things that in other languages would be doable, but one of the advantages of C++ is that it is so strict. So if you can extend an object pretty much everywhere in any way, shape or form you want, it becomes difficult to track what your object is actually capable of if you have some more libraries which might add own things and so on. Here you are limited to just simple properties, and since this is limited that you cannot use functions, this mechanism usually will not be used too excessively. You can also get, I think you should be able also to list properties. Yeah, dynamic property name. This will give you a list of all the names of all the properties that are available. So if you would want to see if some properties have been attached to an object, you can also list them this way. Okay, I think this is enough for today. So we didn't really have a break. We just waited at the beginning for some time. In principle, we can make a 15-minute break during the lecture since it's 3 hours, but the time slot is from 3 to 5:30 there. So 3 hours, like 3 lecture hours, would be 15 minutes less than our time slot. So we can either start a bit later or end a bit sooner or make a break in the middle. If you have a preference, you can let me know. If you prefer to be done earlier, or if you prefer to start later, or if you would want to have a break in the middle to digest all the things you have heard. I'm known for talking a bit fast, so so sorry about that. But that's why there is the recording. While I watch YouTube usually in double speed, other people can watch my YouTube in half speed if they prefer to do so. So I will upload the project to Moodle. I will upload the recording to YouTube and put the link in Moodle. There will be no homework assignment today since it's the first lecture, and this whole Qt thing is really a lot to grasp. So I think just having seen this is good enough. If you want a non-graded optional assignment, you can just skim through the documentation of Qt. I will add a link to this documentation also to the Moodle, this one, the one with all the classes. But as said, this is just a, you can do it if you want, it's not an official assignment. When you are installing the Qt Creator, actually I would recommend you install Qt Creator even if you are going to use Visual Studio later on, because it all the samples that Qt comes with are as Qt Creator projects offered. Although if you want to use them in Qt, you can go here and import or open project file, this one I think. Then you could also open those samples, but I haven't tested if this works flawlessly or if it is maybe a bit spotty. So testing the samples from the Qt Creator is the most reliable option, and there are really many. But since some of you wrote that you prefer finishing early than having a break, so I'll stop the recording.